Hi everyone, welcome to this video dedicated to Makefile. So the idea today is not to bring you at an expert level of using and writing Makefiles, but to understand the basics of it, such that if you encounter one in the future, then you are not completely lost, so you know a little bit what it is about. So we will go again to our little square root program. Okay, so as a reminder, we have a library. So now it's a dynamic library that is here. Okay, so compute.c contains the implementation of a square root, which is wrong, but okay. Right, and this is compiled as a shared library. We'll see it in a minute. And we have an example code. So that is, so the main is here in my square root. Okay, and I've further split my square root in two files. So let's have a look at this again, because it has changed a little bit. So now my square root has only a main and it calls two routines. So check command line is in the command line.c now. Okay, so check command, that's strictly the same routine, okay, as before, but it's in a different file. So that will help us to that will help me to illustrate a feature of Makefiles. And then the second one is my square root. Okay, and that's a routine that is part of the dynamic library. Okay, good. So for now, since the beginning of this series of videos, we have used a shell script compile.sh, and the idea is to replace it with a Makefile. So let's have a look at this shell script again. So we define some shell variables here. So C flags that are the compile flags. Lib square root is the library that will be passed to link our application. Build, so objdr contains the directory name where we want the objects to be. Include is the different directories that we have to include in order to compile our objects. And libdir contains the directories, all the directories where we want to link libraries. Okay, that the libraries we want to link against, they are in directories, and we want all these directories to be part of libdir. So set -x is just to have some display on the command line, and here is the compilation. So here we compile two objects. We have the flags, the include, that's the name of the object, so we have the possibility to put it in the objdr. -c to tell that okay, that's separate compilation, and that's a source file. Okay, so that's the one that will be used for our library. And here it's my square root, so that's the that's our main. Here we define that's how we create the dynamic libraries. We've seen this in the previous video, and that's how we link everything together. So that's our application we want to build, that's our main, that's the dir, and that's the libs against which we want to link, and that's the execution of the file. Good. We want to replace this with a Makefile. So I've created one. It's not the easiest one. There are already some features that are used, but still it's a simple basic Makefile, and we'll improve it a little bit. Okay, so first, okay, I define a shell variable. That's I'm not using, so maybe you can just suppress this one. Okay, here I clear suffixes. By default, Makefile takes care about some file with some extension. Here I say, okay, don't care about anything, and then now care about .o file, .c file, and .h file, and all the rest you don't care. Good. Then I define some directories here. So root dir is the root of my project, and that's the current directory because I've put my Makefile at the top of my directory. Then I have a src dir that will contain all the sources. That's the directory where all the sources of my library is. The build dir that where I want to all the objects, file, and all application and libraries that I want to build here. And example dir, that's the directory where all sources of the application are. Column equal is the symbol to affect a value to a variable. Okay, so here and here I'm using the value of root dir, okay, that is defined here, and then I append /src, and so that's the same for these three. Okay, so here that's yet another variable, but it's cc, and that's a convention. You can call it compiler or whatever, any other string that would work. By convention, general cc is the C compiler. Good, and then we start to have two sets of variables that are different. So one for the library and one for the application. So the square root library, I have two flags. So -fpic, so that's for position independent code. So that's what we need to build a shared library, okay, dynamic library. Wrong is that because I want to compile it to have our wrong implementation of square root. So lib square t, okay, I will need to link against the mathematical library here. Include and libdir square t, we don't need anything, so these variables are set empty, but it's a good practice to still define them and use them in the following, such that the day where you want to add something here, the variables exist already, okay? Even if at the beginning it's empty, at some point maybe in the life of your project, this might change. And then sqrt is the name of the library we want to build. So, and I want it to be in the build dir, okay, and libsqrt.so, okay, and that's a new variable. I define the same for the application, so this time there is no compilation flag. I will compile against the lib square root that is defined here, okay. Well, it's not defined here, well, all the variables for it are defined here. This time I will have several includes, so src dir, so that's to be able to include compute.h, and example here as well, because now we have a command line.h as well, so I need a second include here. Libdir, okay, I will need to link against the lib square root that will be in the build dir, so I have to add this -L build dir, and that's the name of my application. I want to build it, and that's it. Everything is in the build dir, so it's my square root but in the build dir. Good. So from the beginning up to here, execution of the Makefile is it's one line after the other, starting from the beginning up to here. Starting from now, execution is not anymore in the order of the lines that are defined. There is a notion of target that comes into play. So here we define a target name. So $app, so it's basically the value of the app variable, and it's here. So okay, and then I want that's replaced by this. Okay, build dir my square root. So basically it will be build / my square root. And okay, and then you say, okay, that's my target, and that's what I want to build. I want to build my application. Then I put a colon, okay, and so before the colon is the definition of the target. After the colon are the different objects, the dependencies. So what do I need in order to build this app? What do I need? what do I need basically? And so I will need my library, I will need the square root.o, and I will need command line.o as well. compute.h, I do need it, yes, because I will need to, I don't need really to compile it, but yes, we will see why it's a good idea to also include this kind of thing. And then this, if in order to create, so to create this target, so I need these dependencies. As soon as I have all these dependencies here, I'm able to do something. Okay, and do something here is basically link everything together. So that's the linking stage of my application. So how do we read this? So $cc, so that will be GCC. Okay, that's our compiler. -o, so that's where I want to define the name of my application. And then here I'm using $at. $at is basically the target. So okay, $at is the target, so it will be replaced by $app. So here you can, we will see, we will be able to read build / my square root. And then I put all the objects, so my square root command line.o, $libdir app, so that's this variable, so my will be replaced by -l build basically, and libs app, so all the libraries I want to link against. Okay, and then that will be replaced by my -l square root. Okay, good. So, but then at the beginning, when I have nothing defined, so I don't have the library, I don't have any .o. Okay, so I have to define all the targets in order to build them. So, for example, here, in order to build dir / my square root.o, I need what? I need example dir my square root.c. And how do I obtain this guy? $cc, so I compile GCC with the C flags of the application, the include of the application, -o the target I want to create, okay, and -c for separate compilation, and $inferior in order to tell, so okay, please give me the first dependency. Okay, so then I will give this one. So this will end up in GCC -i source directory, so src -i examples -o build / my square root.o -c examples / my square root.c. We will see this in a minute. Okay, command line is the same basically. Okay. Then square root, so that's the library. So what do I need to build the library? I need the compute.o. Okay, once I have the compute.o, I call GCC -shared -o $at, so same, that's the target, and then I link all the objects and all the library I want to link against, and that's exactly the same as before for my square root and command line. That's separate compilation of compute.c. Okay, and it's only just now I have the C flags are different, so I'm using the C flags of square root and include of square root instead of the app like we were using in the two lines here. And that's it basically. And I have one additional target which is clean. Okay, so the phony here just say if it's just help in case I have a clean a file that whose name is clean. Okay, so that's a good practice to put phony here. And as all my objects, libraries, and application are in the build directory, I just have to erase everything that is in build. That's all. I don't have. So then the clean target is pretty simple. So here clean is the target. Okay, column. It has no dependencies, so it can be executed right now, and I can and the command I want to execute is this one. One caveat here. So one issue when you are not familiar with Makefiles is that this character is a tab character. You don't have the right to put here space. If here I've put 2 space, you see it really looks like it's the same thing, but it's not the same for make. Here you see my editor is telling me, ooh, that's not a good idea to put space here. So then I have really to put a tab here to have a correct Makefile. Right, let's do this. And then the command is just make, and by default, when you don't specify anything, it will look for a file named Makefile. And then my Makefile is here, right? Okay, it's in the root direction, in the root of my project. So we just type make, and so as you can see, things are not executed in the order where it appears in the Makefile. So as we didn't specify any target, it will create this one. Okay, then looks for dependencies. So is square root available? No. Okay, then I build square root. Okay, is compute.o available? No. Then I have to compile it. Okay, compute.o. Okay, is src compute.c available? Yes. Okay, then I can create this one. Then okay, then compute.o is available. Okay, then I can create the library. Okay, and then I come back here. So square root is available now. Build here my square root.o. Is it available? Yes, no, it's not. So okay, then I have this target that enables to build it. Is my square root.c available? Yes. Okay, then I can compile. Same for command line, and then same for compute.h. So this is already available, and then in that case I can do the linking stage, and that's exactly what happens. So first there is a compute.c and then the creation of the library. Okay, then separate compilation of my square root and command line, and finally linking stage of my application. So I'm linking all the .o and a link against the square root library. Okay, clear? Good. And then make clean. So that's another target. And then now I am executing. So the rm command. Now I have nothing else anymore in the build directory. So we've just seen the basics of Makefile mechanics on a simple project, rather simple. Not Hello World completely, but still pretty simple. So that's it for this video. There is another one where we'll go a little bit deeper into some inference rule and some internal function of Makefile. Thank you for watching. Goodbye.